So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
Welcome to a video on composite functions. A composite function can be thought of as a combination of two functions. One way to illustrate this would be to use a conveyor belt where we have an initial input, let's say 3. One way to illustrate this would be to use a conveyor belt where we have an initial input, let's say 3, and it becomes the input into F, where F squares its input and produces an output of 9. And this output becomes the input into G. So we multiply 2 times 9, and the final output of this composite function would be 18. Now the order in which we evaluate a composite function is extremely important. So for example, if we have the same functions, but now we reverse the order, and we start with the same input of 3, function G would multiply that by 2, producing an output of 6, which becomes the input into F, and 6 squared would be 36. So notice if we change the order in which we compose functions, the outputs in most cases will be quite different, even though our inputs may be the same. The formal definition of a composite function states, given two functions f and g, the composite function denoted using this notation is read f composed with g, or just f of g. And we need to be careful not to confuse this symbol here with a multiplication sign. Notice for a composition of functions it's a hollow circle, whereas for multiplication it would be solid. Below here we see 3 equivalent ways to represent a composition of functions. Remember, for a composite function, the order in which we compose the functions is extremely important. Therefore, when we're given a composite function, we're going to rewrite it in this form here, because this tells us that we're going to first evaluate function g at the value of x, and the output of that will be the input into function g. So we're going to evaluate function g first, and then function f, if the composition of functions is written in this way. And that's almost in the opposite direction that you might think. Notice the f comes before the g, but when it comes to evaluating, the given value of x will first be the input into g, and that output will become the input into f. Let's go ahead and look at some examples. If we want to evaluate f of g of 3, this is going to be equal to f of g of 3 written this way. And so this tells us that we will find the value of g of 3 first, and that result will be the input into f. So let's go down here on the side and find g of 3. G of 3 will equal 3 cubed minus 5. Well, that'll be 27 minus 5, which is equal to 22. Since g of 3 is equal to 22, this just becomes f of 22. We found g of 3, and it was equal to 22. Now 22 will become the input into f. Notice here f multiplies the input by 2 and then subtracts 1. So we have 44 minus 1, so we have 43. So f of g of 3 is equal to 43. Let's go ahead and take a look at another one. Notice this question has the same input, but now instead of f of g, it's g of f. So this is equal to g of f of 3. So now we're going to find f of 3 first. Let's go down here and do that. F of 3 is equal to 2 times x minus 1, or 2 times 3 minus 1. That'll be 6 minus 1, or 5. So f of 3 is equal to 5, so we can replace this with 5. So this becomes g of 5, and g of x is equal to x cubed minus 5, so we'll have 5 cubed minus 5. So that's 125 minus 5, which is equal to 120. So this will be the value of g of f of 3. Let's try another. We want h of g of negative 1. Well, this is equal to h of g of -1 written this way, and this should key us in to evaluate g of -1 first. So we'll go ahead and do this on the side. G of -1, well, g of x is equal to x cubed minus 5, so we have -1 cubed minus 5. Well, this will be -1 minus 5, or -6. So g of -1 is equal to -6, so now we can rewrite this as h of -6. So now we replace x with -6 in h, so we'll have 5 minus -6 squared. Watching our signs here, we're going to have 5 minus a positive 36, which is equal to a -31. So h of g of -1 is equal to a -31. Okay, now there's one other type of problem we need to look at. Notice on this problem they don't give us an initial input. So what we're going to have to do is input one of the functions into the other function, and again it's important that we follow the correct order. So remember, this is the same as f of g of x, which by definition is equal to f of g of x written this way. Notice there's no x value to input into g, so the only thing we can really do is replace g of x with x squared minus x plus 5. So we need to determine f of x squared minus x plus 5. So if there's no value to input into g, we have to replace g of x with the entire function. So now wherever we see an x in f, we'll replace it with this entire expression. So instead of 4x plus 1, we'll have 4 times the quantity x squared minus x plus 5 plus 1. So we'll distribute the 4 and then combine any like terms. So 4x squared minus 4x plus 20 plus 1. So f of g is equal to 4x squared minus 4x, and we'd have plus 21. Sometimes these are a little tricky when you first do these, but the process is exactly the same, except instead of having a numerical value, you have to substitute an entire function into the other function. Let's try one more of these. Now we have g of f instead of f of g, so this is equal to g of f of x. Again, we don't have an input to put into function f, so we're going to rewrite this as g of f of x is equal to 4x plus 1. So wherever we see an x in g, we'll replace it with 4x plus 1. So we're going to have, instead of x squared, we'll have 4x plus 1 squared minus 4x plus 1 plus 5. Here we're going to have to square 4x plus 1. There's no shortcuts here. We're going to have 4x plus 1 times 4x plus 1. This will be minus 4x minus 1 plus 5. Okay, so we're going to have 16x squared plus 4x, that's plus 8x, plus 1 minus 4x, this would be plus 4. And one last step. When we have one last step, you can see this type of problem is a lot more work. We're going to have 16x squared plus 4x. Here we have a positive 1 and a positive 4 plus 5. And notice that when we change the order of the composition, the result was quite different from what we had on the previous screen. One last comment I'd like to make. If we did determine f of g and it was equal to g of f, which was equal to x, then the two functions have a special relationship and they are inverses of one another. And this topic will be covered in another video. So thank you for watching and have a good day.